It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
This is Umamaheswara Rao. PYQs of Linear Algebra. The number of distinct eigenvalues of the matrix. Here the matrix is triangular matrix. That's why eigenvalues are nothing but its leading diagonal elements. Here distinct eigenvalues means 2, 1, 3. Because 2 is repeated eigenvalue, that's why I have taken only once. So how many number of distinct eigenvalues here? 2, 1, 3. Total 3 distinct eigenvalues. Next column, rank of the matrix. The rank of the matrix. First I am applying the operation R1 interchange with R3. If I interchange R1 with R3, I'll get one, 1, 0, 1, 0, 1, 0, 1, 1. Now apply the operation R2 minus R1. By applying R2 minus R1, we get 1, 1, 0, 1 minus 1, 0, 0 minus 1 minus 1, 1 minus 0, 1, 0, 1, 1. Now it is not in echelon form. That's why we have to apply another operation R3 plus R2. By applying the operation R3 plus R2, we get 1, 1, 0, 0 minus 1, 1, R3 plus R2, 0 plus 0, minus 1 plus 1, 0, 1 plus 1, 2. So 0, 0, 2. It is clearly in echelon form. Number of non-zero rows equal to 3. Therefore, rank of A is 3. Next column. Matrix M is 2 cross 2 with eigenvalues 4 and 9. The eigenvalues of M square are, eigenvalues of A are 4 and 9. Eigenvalues of A square are, we have direct property, Lambda is eigenvalue of A, lambda square is eigenvalue of A square. That's why 4 square, 9 square. That is 16 and 81. So the eigenvalues are 16 and 81. Next column. Consider a 2 cross 2 matrix V1 V2 where V1 V2 are column vectors and M inverse is U1 transpose and U2 transpose, where U1 transpose and U2 transpose are row vectors. V1 V2 are column vectors, U1 U2 are row vectors. U1 transpose and U2 transpose are row vectors. Then consider the following statements. U1 transpose dot V1 equal to 0, U2 transpose dot V2 equal to 1. U1 transpose dot V2 equal to 0, U2 transpose dot V1 equal to 0. So here the given data M into M inverse equal to I, that is given in the data. He has given that U1 transpose, M inverse into M equal to M into M inverse equal to I, that is given in the data. So here M inverse is U1 transpose U2 transpose. M is given as V1 V2 equal to 1 0 0 1. From this, one is M, another one is M inverse. M inverse into M is generally I. So here U1 transpose dot V1 is 1. U1 transpose dot V2 is 0. U2 transpose dot V1 equal to 0. U2 transpose dot V2 equal to 1. After comparison we got. Now we have to examine the statements. If you look at the result, U1 V1, here U2 V2. In these two cases you got 1. That's why statement 1 is true. U1 V2 and U2 V1 you will get false. This is also true because you got 0. U2 transpose dot V1 and U1 transpose dot V2, that is also 0. That's why both are correct in this problem. Both the statements are true in this problem. Last option is correct. Understood? Next problem. The given set of equations x plus y plus z equal to 1, ax minus ay plus 3z equal to 5, 5x minus 3y plus az equal to 6 has infinitely many solutions if a is equal to. First you have to write the given non-homogeneous system in augmented matrix form. 1 1 1. A minus A 3 5, 5 minus 3A 6, that is augmented matrix AB. Now apply the operations. R2 minus AR1 R3 minus 5R1. A R1, A minus A, 0. Minus A minus A, minus 2A. 3 minus A, 5 minus A. Next, R3 minus 5R1. 5 minus 5, 0. Minus 3 minus 5, minus 8. A minus 5. 6 minus 5, 1. Now, here you have to apply an operation to get into echelon form. AR3 minus 4R2. AR3 minus 4R2. So we have to write first row as it is. 1, 1, 1, 1. Second row as it is. 0 minus 2A. 3 minus A, 5 minus A. AR3. A into R3, 4 into R2, 0. Second term also 0. First two entries are 0, 0, 0. Next, A square minus 5A plus 4A, that is A square minus A minus 12. Next, A plus 4A, that is 5A minus 20. A minus 20. Given that the system has infinitely many solutions, that means rank of A equal to rank of AB less than number of variables. That is possible only when only when A square minus A minus 12 equal to 0 and also 5A minus 20 equal to 0. 5A minus 20 equal to 0 means A equal to 4. If you substitute A equal to 4 here, that is also satisfying. Therefore, A is equal to 4 is the correct answer. So, which option is correct? First option is found correct. A equal to 4. Yeah, in matrix equation, AX equal to R, AX equal to R, then one of the eigenvalue of A. Here, AX equal to R, then one of the eigenvalue of A. Given that AX equal to R, A is provided in the data, X is provided in the data, R is also provided in the data. Now, A is 484. 816 minus 4. 4 minus 4, 15. 4 minus 4, 15. 2, 1 4. 32 16 64. Now, if you multiply LHS, you will get 4 to the 8 plus 8 plus 16, 32. 16 plus 16 minus 16, 16. 8 minus 4 plus 60, 64. Now, this is nothing but 32, 16, 64. That can be written as 16 of 214. It is in the form of 16x. Ax, this is A, this is x. Ax equal to 16x. Therefore, one of the eigenvalue of the matrix is 16. Understood? Next column. Euclidean norm of the vector. Euclidean norm of the vector is nothing but length of the vector. 4 minus 2 minus 6. 4 minus 2 minus 6. This is x. Now length of the vector x is square root of 4 square plus minus 2 whole square minus 6 whole square, that is 16 plus 4 plus 36, that is square root of 56. Square root of 56. Next, the inverse of the matrix 2 3 4 4 3 1 1 2 4 is, whenever you are going to find inverse by adjoint A by det A, consumes time. That's why use simple logic. A into A inverse is always I. That's why use the options. First row of A multiply with first column of A inverse. If A into A inverse must be I, identity matrix. That's why first row of A I am going to multiply with first column of each option. If I get 1, I am going to multiply second row with second column. Suppose if the answer is not 1, I can eliminate that option easily. Observe. 2 multiplied with minus 10, minus 20, plus 3 into 15, minus 20 plus 45, minus 20 plus 45, 25, 25 into 4 into minus 5, 25 minus 20, 5. It is not 1. Eliminate this option. Next. Select second option. First row of A multiplied with first column of A inverse. Multiply. What is the result? Verify. 2 into 2, 4 minus 9 plus 4 minus 1. That's why eliminate this option. Next one. Third option. 2 3 4 multiplied with minus 2 3 minus 1. What is the result? 2 into minus 2 minus 4 plus 3 3 ja 9 and 4 into minus 1 minus 4. The result is 1. First 1th entry is 1. Okay. Next, if you multiply first row with first column of last option, 20 minus 45, 4 5 are 20. What is the result? Minus 5. So 1th element should not be minus 5. Therefore, third option is the correct answer. So here I have applied A into A inverse equal to I logic using the options. Understood? Therefore, correct answer is third option. That is the best method rather than using the regular conventional process. Next, consider the system Ax equal to B. The value of x3 is, we have to find the value of x3. Now consider the augmented matrix AB, because it is a non-homogeneous system. Consider the augmented matrix AB. One, 3, 2, 1, 2, 2 minus 3, 1, 4, 4 minus 6, 2, 2, 5, 2, 1. Now R2 minus 2R1, R3 minus 4R1, R4 minus 2R1. By applying these three operations, we get 1, 3, 2, 1. Now R2 minus 2R1, 2 minus 2, 0, 2 minus 6 minus 4, 0 minus 4. Next, minus 3 minus 4 minus 7, 1 minus 2 minus 1. Four minus 4, 0. 4 minus 12 minus 8. Minus 6 minus 8 minus 14. 2 minus 4 minus 2. Next, R4 minus 2R1. 2 minus 2, 0. 5 minus 6 minus 1. 2 minus 4 minus 2. 1 minus 2 minus 1. Now it is not in echelon form. We have to apply R3 minus 2R2, R4, 4R4 minus R2. By applying these two operations, we get 1 3 2 1, 0 minus 4 minus 7 minus 1. Now 0 minus 0, minus 8 plus 8 0, minus 14 plus 14 0. Okay, minus 2 plus 2 0. Next, by applying 4R4 minus R2, 0 minus 0 0, minus 4 plus 4 0, minus 8 plus 7 minus 1, then minus 4 plus 1, that is minus 3. We have to find out x3 value. Here x3 value you can get last row. Observe, actually another operation we have R3 interchange with R4. Without interchanging also you can estimate the answer. X3 equal to minus x3 equal to minus 3, x3 equal to 3. Answer is 3 in this problem. The value of x3 is 3. That is the answer. Next problem. Matrix P is given. We have to find eigenvalues of PR. Before going to find eigenvalues of P, I am going to find out determinant value of P. I can find determinant value very easily with the help of first column. I am expanding determinant by using first column. Minus 2 is in second row first column. That's why the sign of its cofactor is minus. So minus of minus 2 into, eliminate its row and its column. Eliminate its row and corresponding column. What is left? 130 061, 130 061, 016. Okay. Now minus of minus 2 is plus 2. 1 of 36 minus 1, minus 3 of 0 minus 0, plus 0 into anyhow you will get 0. Now 2 into 35, that is 70. Determinant value is 70. We know that determinant value equal to product of eigenvalues. That's why verify option wise product of eigenvalues. Here 36 into 3, not 70. 1 into 2 into 5. Second option, 1 into 2 into 5, 10. 10 into 7, 70. Here we have 70. 3 4 is 12, 12 5 is 60, 60 into 7, 420. Now 1 2 3 4, this is not the answer. Only second option is satisfying. Det B equal to 70. Product of eigenvalues equal to 70. Only in second option. That's why second option is correct in this problem. Next problem. These are all properties. All the statements are given on properties. First statement, rank of A equal to rank of A into rank of AB equal to rank of A into rank of B. False. Determinant of AB equal to det A into det B. True. rank of A plus B less than or equal to rank of A plus rank of B, true. Determinant of A plus B less than or equal to det A plus det B, false. Only second statement and fourth statement are true. That's why 2 and 3 are correct. That means third option is correct in the given options. In the given options, third option is correct. Next problem. Consider the following system of linear equations. Which of the following condition ensures that a solution exists for the above system? It is a non-homogeneous system. First you have to consider augmented matrix AB, then you have to reduce into echelon form. That's why I am considering augmented matrix AB. One two B1, 2 4 B2, 3 7 B3, 3 9 B4. Next, R2 minus 2 times of R1, R3 minus 3 times of R1, R4 minus 3 times of R1. By applying these operations, we get 1 2 B1, 0 0 B2 minus 2 B1, R3 minus 3 R1, 3 minus 3, 0, 7 minus 6, 1, 0 1, B3 minus 3 B1. Next, 3 minus 3 0, 9 minus 6 3, 0 3, B4 minus 3 B1. Next, R3 and R2 we have to interchange. R2 interchange with R3 to get echelon form. Now 1 2 B1, 0 1 B3 minus 3 B1, 0 0 B2 minus 2 B1, 0 3 B4 minus 3 B1. It is not in echelon form. Apply R4 minus 3 times of R2. By applying R4 minus 3 times of R2, we get 1 2 B1, 0 1 B3 minus 3 B1, 0 0 B2 minus 2 B1, 0 0 B4 minus 3 B1 plus 9, so minus 6 B1, B4 minus 6 B1 minus 3b3 minus or plus 1 minute r4 minus 3r2 0 minus 0 3 minus 3 0 b4 minus 3b1 minus 3b3 plus 9b1 minus 3b1 6b1 plus 6b1, so this is plus 6b1 minus 3b3 now it is in echelon form clearly, but rank is 2, rank of A is 2. Here rank of A is 2. How many variables you have in the system? How many variables you have? x1, x2. Number of variables are 2. Number of variables are 2. Rank of A is 2. Okay. The system has a solution means compulsory rank of AB must be 2. The system possesses solution only when rank of AB must be 2. Therefore, rank of AB must be 2. It is possible only when these two entries must be equal to 0. This entry and this entry must be equal to 0. So B2 minus 2B1 equal to 0. B2 minus 2B1 equal to 0 and 6B1 minus 3B3 plus B4 equal to 0. That's why in the options we have to verify B2 must be equal to 2B1, B2 must be equal to 2B1, 6B1 minus 3B3 plus B4 equal to 0. So last option is correct. Understood? Next column. Let I be the 100-dimensional identity matrix. I be the 100-dimensional identity matrix. E is the set of its distinct eigenvalues, its distinct real eigenvalues, then the number of elements in set E. Simple problem. I be the 100 cross 100 identity matrix. 100 cross 100 identity matrix. 1 0 0 0 0 0 0 1 0 0 0 0 0 1 0 0 0 0 and so on 1. Okay, it is 100 cross 100 identity matrix. If the matrix is identity matrix, eigenvalues are nothing but its leading diagonal elements. Eigenvalues are its leading diagonal elements. Eigenvalues are its leading diagonal elements. So you can understand that 1 is repeated 100 times. 100 times. So what is set E? E is nothing but set of distinct eigenvalues of identity matrix. So any value is repeated, we are not going to take, only distinct values only we are going to take in the set. That's why how many number of elements in set E? One and only one element. One and only one element in set E. Therefore correct answer is the number of distinct elements in set E is 1. 1 is the answer. Next problem. Matrix P is decomposed into its symmetric part S and skew symmetric part V. If S and V are provided, then matrix P. We have one theorem. Every square matrix can be expressed as the sum of symmetric and skew symmetric matrices. So in this problem they have provided symmetric matrix is S, this is S, and skew symmetric matrix is V, this is as V. Therefore we can understand that A is equal to S plus V. S and V are provided in the data. Our job is to find V. We can find easily. Calculate S plus V. You will get automatically A in the option. Observe. Minus 4 plus 0. Minus 4. Minus 4 is in first option. One place is minus 4 in first option and last option. Remaining two options, you have 4 here, minus 2 here. Eliminate these two options. Okay. Next. Verify. First row, third column. 2 plus 3 should be 5. In this option, you have minus 1. That's why eliminate this. 2 plus 3 is 5 in last option. Select last option. So correct answer is last option. Next problem. Multiplication of real valued square matrices of same dimension. Always positive definite. Positive definite means all eigenvalues are positive. It is, you can't say. Multiplication of two real valued square matrices of same dimension. Suppose A is 3 cross 3, B is 3 cross 3. If they are of same dimension, then associative is second option. Yes, matrix multiplication is associative. Matrix multiplication is associative, not commutative. Not always possible to compute. Commutative, not commutative. Okay, so correct answer is associative. Associative is nothing but A of BC equal to AB of C equal to ABC. This is possible. So matrix multiplication always satisfies associative property. Next, for the matrix 1, 5, 3, 3, the eigenvectors are 1, 5, 3, 3. What are the eigenvectors? First you calculate eigenvalues. 1, 5, 3, 3. Determinant of A minus lambda equal to 0. 1 minus lambda 5. 3, 3 minus lambda equal to 0. 3 minus lambda minus 3 lambda minus 4 lambda plus lambda square minus 15 equal to 0. Lambda square minus 4 lambda minus 12 equal to 0. Lambda square minus 4 lambda minus 12 equal to 0. Lambda square minus 6 lambda plus 2 lambda minus 12 equal to 0. Lambda into lambda minus 6 plus 2 into lambda minus 6 equal to 0. From this we can write lambda minus 6 into lambda plus 2 equal to 0. Lambda equal to 6, lambda equal to minus 2. Now we can find eigenvectors very easily using one trick. In the place of lambda, substitute 6, you will get 1 minus 6, 5, minus 5, here 5, 3 minus 6 is minus 3, 3 minus 3, x1, x2, I am calculating eigenvector x1, x2 equal to 0, 0. Take one equation either by using first row or second row. Minus 5x1 plus 5x2 equal to 0. Separate variables. 5x1 equal to 5x2. x1 by 5 equal to x2 by 5. After cancellation, x1 by 1 equal to x2 by 1. Therefore, the eigenvector is 1, 1. 1, 1 in two options. Only one option. 1, 1 is only in second option. That's why second option is correct. That's why second option is correct. Next column. Consider the matrix 1 minus 1 0, 1 minus 2 1, 0 minus 1 1. One of the eigenvector of M is, one of the eigenvector of M is, we have to solve this problem by using options. One of the eigenvector of matrix M is, so if you write Ax equal to lambda x form, observe sum of all elements of each row, sum of all elements of each row, 1 minus 1 plus 0, 0. Sum of all elements of second row, 0. Sum of all elements of third row, 0. We can understand that 0 is one of the eigenvalue. 0 is one of the eigenvalue. That's why I am going to multiply the matrix with options one by one. First, matrix M is, I am going to verify Mx. If I got Mx equal to 0x, we can say that x is the corresponding eigenvector. Observe here, I am taking second option because second option is different from remaining three. Here we have 1 1 minus 1 minus 1 1 minus 1 like that. Here all are positive. I am taking this option. Now 1 minus 1 0, 1 minus 2 1, 0 minus 1 1 multiplied with 1 1 1. Verify. 1 minus 1 plus 0, 1 minus 2 plus 1, 0 minus 1 plus 1. You are getting 0 or not? So Mx equal to 0x is satisfied by second option. That's why second option is correct. Understood? Thank you.